What is cloud computing?
Cloud computing is the on-demand delivery of computing services, servers, storage, databases, networking, and software, over the internet on a pay-as-you-go basis. 5 essential characteristics per NIST. On-demand self-service, provision resources without human intervention, broad network access, available over the network from any device. Resource pooling, provider resources are shared across multiple tenants. Rapid elasticity, capacity can scale up or down almost instantly. Measured service, usage is metered and billed accordingly.
What are the different types of cloud computing?
Public cloud, infrastructure owned and operated by a third-party provider, AWS, Azure, GCP. Shared across tenants and accessed over the internet. Private cloud, dedicated infrastructure for a single organization, hosted on-premises or by a provider. Offers greater control and security. Hybrid cloud, combines public and private clouds, allowing data and workloads to move between them based on policy, cost, or compliance needs. Community cloud, shared infrastructure for organizations with common concerns, for example, healthcare, government, managed jointly or by a third party.
What are the benefits of cloud computing?
Scalability, scale resources up or down to match demand, cost efficiency, no upfront hardware investment. Pay only for what you use. Flexibility and accessibility, access resources from anywhere with an internet connection. High availability, providers offer multi-region redundancy and SLA-backed uptime. Disaster recovery, built-in backup, replication and recovery solutions. Speed of deployment, provision infrastructure in minutes instead of weeks. Automatic updates, providers handle patching and maintenance of underlying infrastructure.
What are the different cloud service models?
IaaS, infrastructure as a service, provides virtualized compute, storage, and networking. The customer manages the OS and everything above it. Examples: AWS EC2, Azure Virtual Machines, Google Compute Engine. PaaS, platform as a service, provides a managed runtime environment for developing and deploying applications. The provider manages the OS and middleware. Examples: AWS Elastic Beanstalk, Google App Engine, Azure App Service. SaaS, software as a service, delivers fully managed applications over the internet. The customer only consumes the software. Examples: Gmail, Office 365, Salesforce. Responsibility shifts upward. IaaS gives you the most control and responsibility. SaaS the least.
What is serverless computing?
Serverless computing lets developers run code without provisioning or managing servers. The cloud provider automatically allocates compute resources per request and scales to 0 when idle. Key characteristics: pay-per execution, not per hour. Auto scales instantly with demand, no idle cost when there are no requests. Typically limited by execution timeout, for example, AWS Lambda, 15 min max. Examples: AWS Lambda, Azure Functions, Google Cloud Functions. Best suited for event-driven workloads, API backends, data processing pipelines, and scheduled tasks.
What is virtualization in cloud computing?
Virtualization is the process of creating virtual instances of servers, storage, or networks on top of physical hardware using a hypervisor. It enables multiple vMTCs to share a single physical host. Hypervisor types: Type 1 bare metal, runs directly on hardware. Examples: VMware ESXi Xen KVM Type 2 hosted, runs on top of an OS. Examples: VirtualBox VMware Workstation. Benefits: improved resource utilization, workload isolation, faster provisioning, and simplified disaster recovery.
What is multi-cloud?
Multi-cloud is the practice of using services from 2 or more cloud providers. For example, AWS plus Azure plus GCP. Within a single architecture, why adopt multi-cloud? Avoid vendor lock-in, reduce dependency on a single provider. Best-of-breed services leverage each provider's strengths, for example, GCP for ML, AWS for breadth. Redundancy, survive a full provider outage. Compliance, meet data residency requirements across regions. Challenges, increased operational complexity, inconsistent IPIs, harder networking, and the need for cloud-agnostic tooling, Terraform, Kubernetes.
What is the difference between vertical and horizontal scaling?
Vertical scaling, scaling up/down. Add more CPU, RAM, or disk to an existing instance, simpler to implement but has a hardware ceiling, typically requires downtime during resize. Example, upgrading an EC2 instance from T3, medium to T3. X-large, horizontal scaling, scaling out/in, add or remove instances to distribute load. No theoretical ceiling, supports massive scale, requires stateless application design or external session management. Example, adding more EC2 instances behind an auto-scaling group. Horizontal scaling is generally preferred in cloud-native architectures because it is more resilient and cost-flexible.
What is an availability zone, IZ?
An availability zone is a physically separate data center or group of data centers within a cloud region, each with independent power, cooling, and networking. Key points. IZTCS within a region are connected via low-latency fiber links. Deploying across multiple IZTCS provides fault tolerance. If one IZ fails, others continue serving traffic. AWS, Azure, and GCP all offer multiple IZTCS per region, typically 2-6. Example, AWS
Assist 1.
has 6 IZTCS.
Assist 1A.
Through
Assist 1F.
What is the shared responsibility model in cloud security?
the shared responsibility model divides security obligations between the cloud provider and the customer. Provider is responsible for security of the cloud, physical data center security, hardware and networking infrastructure, hypervisor and host OS patching. Customer is responsible for security in the cloud, data encryption and classification, IAM policies and access control, OS patching for IaaS, application security and firewall rules. The boundary shifts depending on the service model. With SaaS, the provider handles more. With IaaS, the customer handles more.
What is a virtual private cloud, VPC?
A VPC is a logically isolated virtual network within a cloud provider where you define your own network topology. You control IP address ranges, CIDR blocks, subnets, public and private, route tables and internet gateways, security groups and network IC LTCS. Key features: VPC peering connects two VPC TCS privately. VPN gateway or direct connect links a VPC to on-premises networks. Flow logs capture network traffic for auditing. Examples: AWS VPC, Azure VNet, Google VPC.
What is an elastic load balancer, ELB?
An ELB automatically distributes incoming traffic across multiple targets, EC2 instances, containers, IPs, to ensure high availability and fault tolerance. AWS ELB types: Application Load Balancer, ALB, Layer 7, HTTP/HTTPS, supports path-based and host-based routing. Network Load Balancer, NLB, Layer 4, TCP/UDP, ultra-low latency, handles millions of requests/sec. Gateway Load Balancer, GWLB, Layer 3, routes traffic through third-party virtual appliances, firewalls, IDS. Equivalents: Azure Load Balancer/Application Gateway, GCP Cloud Load Balancing.
What is object storage in the cloud?
Object storage is a flat namespace storage architecture where data is stored as objects, each containing the data itself, metadata, and a unique identifier. Characteristics: highly durable, for example, S3 offers 99.9999999% /11 durability. Scales to virtually unlimited capacity, accessed via HTTP/REST APIs, not mounted as a file system. Best for unstructured data. Images, videos, backups, logs, examples. Amazon S3, Azure Blob Storage, Google Cloud Storage.
What is block storage in cloud computing?
Block storage divides data into fixed-size blocks, each with its own address. It behaves like a raw disk and can be formatted with any file system. Characteristics: low latency, high IOPS performance, attached to a single instance at a time, like a hard drive. Best for databases, boot volumes, and transactional workloads. Examples: AWS EBS, Azure Managed Disks, Google Persistent Disk. Block versus object. Block storage is for structured, frequently accessed data. Object storage is for large-scale unstructured data.
What is a content delivery network (CDN)?
A CDN is a globally distributed network of edge servers that caches and delivers content from locations close to the end user, reducing latency and offloading origin servers. How it works: 1. User requests content, for example, an image. 2. CDN checks the nearest edge location for a cached copy. 3. If cached, hit, serves it directly with low latency. 4. If not cached, miss, fetches from the origin, caches it, then serves, benefits: faster page loads, reduced bandwidth costs, DDoS mitigation, and global reach. Examples: AWS CloudFront, Azure CDN, Google Cloud CDN, Cloudflare.
What is an IAM role in cloud security?
An IAM, Identity and Access Management. Role is an identity with specific permissions that can be assumed by users, applications, or services without embedding long-term credentials. Key properties, no password or access keys, uses temporary security tokens, STS. Can be assumed by EC2 instances, Lambda functions, or cross-account users. Permissions are defined via JSON policies attached to the role. Example: an EC2 instance assumes an IAM role to read from an S3 bucket, no access keys stored on the machine. Best practice: always prefer IAM roles over hard-coded credentials.
What is cloud formation in AWS?
AWS CloudFormation is an infrastructure as code, IIC, service that lets you define and provision AWS resources using declarative YAML or JSON templates. Key concepts: template describes the desired resources and their configuration. Stack, a running instance of a template. All resources are created, updated, or deleted together. Change set previews changes before applying them. Drift detection identifies resources that have been modified outside CloudFormation. Equivalents: Terraform Multi-Cloud, Azure Resource Manager, IRM, Google Cloud Deployment Manager.
What is Google Kubernetes Engine, GKE?
GKE is Google Cloud's managed Kubernetes service for deploying, managing, and scaling containerized applications. Key features: autopilot mode. Google manages nodes, scaling, and security automatically. Standard mode, you manage node pools with more control. Built-in integration with cloud logging, cloud monitoring, and artifact registry. Automatic node upgrades and repair. Equivalents: Amazon EKS AWS, Azure Kubernetes Service IKS.
What is Azure DevOps?
Azure DevOps is a suite of development and CI/CD tools for planning, building, testing, and deploying applications. Core services: Azure Boards, Agile Project Management, Kanban, Scrum, Azure repos, Git-based source control, Azure pipelines, CI/CD pipelines supporting any language, platform, or cloud. Azure test plans, manual and exploratory testing, Azure artifacts, package management, NPM, NuGet Maven. Azure pipelines can deploy to any cloud, not just Azure, making it a versatile CI/CD option.
What is a cloud region?
A cloud region is a geographic area containing multiple data centers, availability zones. Each region operates independently and is connected to other regions via the provider's backbone network. Factors for choosing a region: latency, pick the region closest to your users. Compliance, data residency laws may require a specific country, for example, GDPR. Service availability, not all services are available in every region. Pricing, costs vary by region, example, AWS.
Assist 1.
Virginia has 6 IZTKS and is typically the first region to receive new AWS services.
How does AWS Lambda differ from EC2?
AWS Lambda, serverless, runs individual functions in response to events, auto-scales instantly from 0 to thousands of concurrent executions. Build per request and execution duration, MS granularity. Max execution time, 15 minutes, best for event-driven tasks, API backends, data transformations. Amazon EC2, virtual machine. Full virtual server with OS-level access, requires manual or auto-scaling configuration. Build per second/hour for running instances, even when idle. No execution time limit, best for long-running applications, stateful services, custom runtimes. Rule of thumb: use Lambda for short, event-driven workloads. Use EC2 when you need persistent servers, GPS, or full OS control.
What are reserved instances in AWS?
Reserved instances, RIs, let you commit to a specific instance type for 1 or 3 years in exchange for significant discounts, up to 72% off on-demand pricing. Types: standard RIs, highest discount, but locked to a specific instance type and region. Convertible RIs, slightly lower discount, but you can change instance type, OS, or tenancy. Scheduled RIs, reserved for specific recurring time windows, deprecated in favor of savings plans. Savings plans, newer alternative. More flexible commitment-based pricing that applies across instance families and even across services, EC2, Lambda, Fargate.
How do you secure data in cloud storage?
Encryption at rest. Use IES 256 via provider-managed keys, SSES3, or customer-managed keys, AWS KMS, Azure Key Vault, GCP Cloud KMS. Encryption in transit, enforce TLS/HTTPS for all data transfers. Access control, implement least privilege IAM policies, bucket policies, and ICLTKS. Block public access by default. Versioning, enable object versioning to recover from accidental deletes or overwrites. Immutability, use object lock, S3, or immutable storage, Azure, to prevent tampering. Auditing, enable access logging and monitor with AWS CloudTrail, Azure Monitor, or GCP audit logs. Lifecycle policies, automatically transition old data to cheaper storage tiers or delete expired data.
What is the difference between Kubernetes and Docker Swarm?
Kubernetes, steeper learning curve but far more powerful, fine-grained autoscaling, HPI, VPI, cluster autoscaler. Rich networking via CNI plugins, Calico, Cilium, Flannel, built-in service discovery, rolling updates, and self-healing, massive ecosystem. Helm, operators, service meshes, etc. Best for enterprise-grade, large-scale orchestration, Docker Swarm. Simple to set up, built into Docker Engine, basic auto-scaling and overlay networking. DNS-based service discovery, fewer features but lower operational overhead, best for small teams, simple deployments, quick prototyping. Industry trend, Kubernetes has become the de facto standard for container orchestration. Docker Swarm sees limited adoption in production today.
What is a stateful versus stateless application in the cloud?
Stateless applications do not retain any client session data between requests. Each request is independent and self-contained. Easy to scale horizontally. Any instance can serve any request. Examples: REST APIs, static websites, serverless functions, stateful applications. Maintain session or data state across requests. Require persistent storage or session affinity. Harder to scale. Instances are not interchangeable. Examples: databases, WebSocket servers, shopping carts with server-side sessions. Cloud strategy. Design applications to be stateless wherever possible, externalizing state to managed services. For example, Redis for sessions, RDS for databases, S3 for files.
What is autoscaling and how does it work?
Autoscaling automatically adjusts compute capacity based on real-time demand, ensuring performance during spikes and cost savings during lulls. Types: horizontal autoscaling, adds/removes instances, most common in cloud. Vertical autoscaling resizes an existing instance, less common, may require downtime. How it works: a WS example. 1. Define a launch template, IMI, instance type, security groups. 2. Create an auto-scaling group with min/max/desired capacity. 3. Attach scaling policies. For example, add 2 instances when CPU 70% for 5 minutes. 4. A CloudWatch alarm triggers the policy, and new instances register with the load balancer. Scaling strategies: target tracking, step scaling, scheduled scaling, predictive scaling.
What is Terraform and how does it help in cloud automation?
Terraform is an open-source infrastructure as code, IIC, tool by HashiCorp that lets you define, provision, and manage cloud resources using declarative HCL, HashiCorp configuration language. Key concepts: providers plugins for each cloud/service, AWS, Azure, GCP, Kubernetes, etc. Resources, individual infrastructure components, VMs, networks, DNS records. State file tracks the current state of deployed infrastructure. Plan, apply.
Terraform plan.
Previews changes.
Terraform apply.
Executes them, benefits. Multi-cloud single tool for AWS, Azure, GCP, and hundreds of other providers. Version-controlled infrastructure store, TF files and Git. Idempotent, applying the same config repeatedly produces the same result. Modular, reusable modules for common patterns.
How do you handle logging in a cloud environment?
Provider-native tools, AWS, CloudWatch logs, application logs, CloudTrail IPI audit logs, Azure, Azure Monitor, Log Analytics Workspace, GCP, Cloud Logging, formerly Stackdriver, Cloud Audit Logs, best practices. Centralize logs, aggregate into a single platform, ELK Stack, Datadog, Splunk, or Provider Native. Use structured logging, emit logs as JSON for easier parsing and querying. Set retention policies, balance cost versus compliance requirements. Correlate with tracing, integrate with distributed tracing, X-ray, Jaeger Open Telemetry. For end-to-end visibility. Alert on anomalies. Configure metric filters and alarms for error spikes or unusual patterns.
What is a Bastion host and why is it used?
A Bastion host, jump box, is a hardened, publicly accessible server that acts as the sole entry point for SSH/RDP access to instances in private subnets. Why use one? Private instances have no public IP and are not directly reachable from the internet. The Bastion reduces the attack surface. Only one host needs to be secured and audited. All access is funneled through a single point, enabling centralized logging, modern alternatives. AWS Systems Manager Session Manager, browser-based shell access with no open inbound ports. Azure Bastion, fully managed PaaS Bastion service. These eliminate the need to manage a Bastion EC2 instance entirely.
What is a service level agreement, SLA, in cloud computing?
An SLA is a formal contract between a cloud provider and a customer that defines guaranteed service levels. Typical SLA components: uptime guarantee. For example, a WSEC2 guarantees 99.99% monthly availability, tilde 4.3 min downtime/month. Performance metrics: latency, throughput, response times. Support response times. For example, critical issues acknowledged within 15 minutes on enterprise support. Remedies: service credits if the SLA is breached. For example, 10-30% credit for downtime. Important: SL as guarantee availability, not durability or data integrity. Those are separate commitments.
How do you optimize cloud costs?
Right-size resources, match instance types to actual workload needs, eliminate over-provisioned instances. Use commitment discounts, reserved instances, savings plans, or committed use discounts, GCP. Leverage spot/preemptible instances, up to 90% savings for fault-tolerant workloads. Autoscale, scale down during off-peak hours. Scale to 0 where possible, serverless Fargate. Monitor and alert. Use AWS Cost Explorer, Azure Cost Management, or GCP billing reports to track spend. Storage tiering, move infrequently accessed data to cheaper tiers. S3 Glacier, Azure Cool/Archive. Delete waste, terminate unused instances, unattached EBS volumes, stale snapshots, and idle load balancers. Tag everything, enforce tagging policies to attribute costs to teams/projects.
What is Kubernetes Federation?
Kubernetes Federation, KubeFed, allows you to manage multiple Kubernetes clusters from a single control plane, synchronizing resources across them. Use cases: multi-region HI, distribute workloads across clusters in different regions for disaster recovery. Multi-cloud, run clusters on AWS, Azure, and GCP simultaneously. Data sovereignty, keep workloads in specific geographic clusters for compliance. How it works: a federation control plane propagates resource definitions, deployments, services, config maps to member clusters. DNS-based service discovery routes traffic to the nearest healthy cluster. Note: KubeFed v2 is the current implementation. Many teams also use tools like Admiralty, Lico, or ClusterNet as alternatives.
How does chaos engineering apply to cloud environments?
Chaos engineering is the practice of intentionally injecting failures into a system to test its resilience and uncover weaknesses before they cause real outages. Principles: 1. Define a steady state, normal system behavior. 2. Hypothesize that the steady state will hold during a failure. 3. Inject a real-world failure, instance crash, network partition, latency spike. 4. Observe the actual impact and compare to the hypothesis, tools. AWS Fault Injection Service, FIS. Managed chaos experiments on AWS resources. Netflix Chaos Monkey randomly terminates instances in production. Gremlin, SaaS platform for chaos experiments. Litmus, open source chaos engineering for Kubernetes. Example: kill a random EC2 instance to verify that autoscaling replaces it, and the load balancer reroutes traffic without user impact.
What is a Kubernetes operator?
A Kubernetes operator extends the Kubernetes API to automate the management of complex, stateful applications using custom controllers and custom resource definitions, CRDs. How it works: define a CRD that represents your application. For example,
Postgres cluster.
a controller watches for changes to that CRD and reconciles the actual state to the desired state. The operator encodes domain-specific operational knowledge, backups, failover, scaling, upgrades. Examples: Prometheus operator automates Prometheus deployment and configuration. Strimzi manages Apache Kafka clusters on Kubernetes. Cloud Native PG manages PostgreSQL clusters with automated failover. Build tools: Operator SDK, Go, Ansible, Helm, KubeBuilder, KUDO.
How do you implement multi-region deployments?
Data replication. Use synchronous replication for RPO equals 0, costly, adds latency, or asynchronous for near zero RPO. Examples: Aurora Global Database, Cosmos DB multi-region writes. Traffic routing. Use DNS-based routing, AWS Route 53, Azure Traffic Manager, with latency-based, geolocation, or failover policies. Failover mechanism. Automate regional failover with health checks. Define RTO/RPO targets. Infrastructure as code. Deploy identical stacks to each region using Terraform or CloudFormation stack sets. Stateless services. Design apps to be stateless so any region can serve any user. Challenges: data consistency across regions, CIP theorem, increased cost and complex debugging.
What is a Cloud Access Security Broker, CISB?
A CISB is a security enforcement point that sits between cloud users and cloud service providers, providing visibility, compliance, data security, and threat protection. 4 pillars of CISB. Visibility, discover all cloud services in use, including shadow IT. Compliance, enforce regulatory requirements, HIPAA, GDPR, SOC2. Data security, DLP, data loss prevention. Encryption and tokenization, threat protection, detect anomalous behavior, compromised accounts, and malware. Examples: Microsoft Defender for Cloud Apps, Netscope, Palo Alto Prisma Access, Zscaler.
How do you ensure compliance in cloud environments?
Adopt compliance frameworks, HIPAA Healthcare, PCI-DSS Payments, SOC2 Service Orgs, GDPR EU Data, FedRAMP US Gov. Enable logging and auditing. AWS CloudTrail, Azure Activity Log, GCP audit logs for a complete audit trail. Automate compliance checks. AWS config rules, Azure policy, GCP organization policies to continuously evaluate resource configurations. Encrypt everything, data at rest and in transit, using provider-managed or customer-managed keys. Enforce least privilege access, IAM policies, SCPs, service control policies, and regular access reviews. Use compliance dashboards. AWS Security Hub, Azure Security Center, GCP Security Command Center for a centralized posture view.
What is Zero Trust security in cloud environments?
Zero Trust is a security model based on the principle never trust, always verify. No user, device, or network is inherently trusted. Every request must be authenticated, authorized, and continuously validated. Core tenets: verify explicitly, authenticate, and authorize based on all available data points, identity, device, location, risk level. Least privilege access: grant only the minimum permissions needed for the shortest duration. Assume breach, design as if the network is already compromised. Minimize blast radius with microsegmentation, implementation in the cloud. Identity-aware proxies, Google Beyond Corp, Azure ID conditional access. Microsegmentation, security groups per workload, service mesh mutual TLS. Continuous monitoring and anomaly detection, short-lived credentials, and just-in-time access.
How does serverless architecture improve scalability?
Serverless platforms handle scaling entirely at the provider level, removing the need for capacity planning. How it scales. Each incoming request can trigger a new function instance concurrently. Scales from 0 to thousands of instances in seconds. Scales back to 0 when idle, no cost when not running. Why this improves scalability? No need to pre-provision or predict capacity. No instance warm-up time for most request patterns. Provider manages the underlying fleet, OS patching, and load distribution. Limits to be aware of. Concurrency quotas, for example, a WS Lambda default, 1,000 concurrent executions per region. Cold starts for infrequently invoked functions and max execution duration.
What is an egress charge in cloud pricing?
An egress charge is a fee for data transferred out of a cloud provider's network. For example, from an AWS region to the internet or to another cloud provider. Key pricing patterns. Ingress is typically free. Uploading data into the cloud costs nothing. Egress to internet is charged, per GB fees that decrease at higher volumes. For example, AWS. $0.09/GB for the first 10 TB. Cross-region transfer, charged at a lower rate than internet egress. Same IZ transfer, usually free. Cross-IZ within a region incurs a small fee, cost optimization tips. Use a CDN to cache content at edge locations, reduces origin egress. Keep traffic within the same region/IZ when possible. Use VPC endpoints or private links to avoid public internet routing. Compress data before transfer.
What are the risks of vendor lock-in, and how do you mitigate them?
Vendor lock-in occurs when a company becomes so dependent on a single cloud provider's proprietary services that switching providers becomes prohibitively expensive or complex. Risks. High migration costs, re-architecting, data transfer fees, limited negotiating leverage on pricing, dependency on provider's roadmap and reliability. Compliance challenges if the provider doesn't expand to required regions, mitigation strategies. Use open source and portable tools. Kubernetes, Terraform, PostgreSQL over provider-specific equivalents. Containerize workloads, Docker containers run on any cloud. Abstract provider-specific APIs. Use adapter patterns or multi-cloud SDK tickets. Multi-cloud strategy, distribute critical workloads across providers. Avoid deep coupling. Evaluate the portability cost before adopting proprietary services. For example, DynamoDB versus PostgreSQL.
What is Kubernetes pod affinity and anti-affinity?
Pod affinity and anti-affinity let you control where pods are scheduled relative to other pods, based on labels and topology. Pod affinity, co-locate pods on the same node/zone, for example, place a cache pod on the same node as the app pod for low latency. Pod anti-affinity, spread pods across different nodes/zones. For example, ensure replicas of the same app run on different nodes for high availability. Example, anti-affinity to spread backend pods across nodes.
Code affinity, pod anti-affinity, required during scheduling, ignored during execution. Label selector, match expressions, key app. Operator in values, backend, topology key, Kubernetes/hostname.
Rule types.
Required during scheduling.
Hard rule, pod won't schedule if unsatisfied.
Preferred during scheduling.
Soft rule, scheduler tries its best.
How do you prevent DDoS attacks in cloud environments?
Layer 3/4 protection, network/transport, a managed DDoS services, a WS Shield, standard is free, advanced for enhanced protection. Azure DDoS protection, GCP Cloud Armor. Network IC/LTKS and security groups, restrict traffic to known ports and IP ranges. Anycast routing, distribute attack traffic across multiple global PO-PTKS. Layer 7 protection, application, Web Application Firewalls, WAF. AWS WAF, Azure WAF, Cloudflare WAF, filter malicious HTTP requests. Rate limiting, throttle excessive requests from single IP tickets or patterns. Bot detection, challenge suspicious traffic with CIPTCHIs or JavaScript challenges. Architectural defenses. Use a CDN to absorb traffic at the edge. Autoscale to handle legitimate traffic spikes. Maintain runbooks for DDoS response and conduct regular drills.
What is confidential computing in the cloud?
Confidential computing protects data while it is being processed, data in use. By performing computation inside hardware-based trusted execution environments, TEEs. Why it matters. Traditional encryption protects data at rest and in transit, but data must be decrypted in memory for processing, making it vulnerable. Confidential computing closes this gap. How it works? TEEs create isolated memory enclaves that even the host OS, hypervisor, and cloud provider cannot access. Data is encrypted/decrypted only inside the enclave. Attestation verifies the integrity of the TEE before sharing sensitive data. Provider offerings, AWS Nitro enclaves, isolated compute within an EC2 instance. Azure Confidential Computing, DCSV2/DCSV3 VMs with Intel SGX or IMD SEVSNP. Google Confidential VM Tickets. IMD SEV-based encryption of VM memory.
What is a policy as code approach in cloud security?
Policy as code, PASI, defines security, compliance, and operational rules as machine-readable code that is version-controlled, tested, and automatically enforced. Benefits. Automated enforcement. Policies run continuously, not just during audits. Version-controlled, track changes, review in PR tickets, roll back if needed. Consistent, same rules applied across all environments, dev, staging, prod. Shift-left security, catch violations in CI/CD before deployment. Tools. OPA, Open Policy Agent. General Purpose Policy Engine using Rego language, HashiCorp Sentinel, Policy Framework for Terraform Enterprise. AWS Config Rules. Evaluate AWS resource configurations against custom rules. Azure Policy. Enforce organizational standards across Azure subscriptions. Chekhov/TFSec, static analysis for Terraform/CloudFormation templates.
How do you implement cloud governance?
Cloud governance is the set of policies, processes, and controls that ensure cloud usage aligns with organizational goals for security, compliance, and cost management. Key pillars. 1. Identity and access. Enforce least privilege access with IAM policies and SCP tickets. Require MFI for all human users. Conduct regular access reviews and remove stale permissions. 2. Cost management. Set budgets and alerts, AWS budgets, Azure cost management. Enforce tagging policies for cost attribution. Review spending reports regularly and right-size resources. 3. Compliance and security. Automate compliance checks with AWS config, Azure policy, or GCP org policies. Define guardrails using service control policies or management groups. Enable centralized logging and security monitoring. 4. Operations. Standardize deployments via IIC, Terraform, CloudFormation. Use landing zones or account vending machines for new projects. Maintain a cloud center of excellence, CCOE, to guide teams.
What are the best practices for cloud security?
Identity and access. Enforce least privilege IAM policies. Avoid using root/admin accounts for daily work. Require MFI for all user accounts. Use IAM roles, not long-lived keys. For service-to-service communication, data protection. Encrypt data at rest, IES 256 via KMS. And in transit, TLS 1.2+. Block public access to storage by default. Classify data and apply appropriate controls per sensitivity level. Network security. Use private subnets for backend services. Expose only load balancers publicly. Implement security groups stateful and NICLs stateless. As defense in depth. Use VPN or private links for hybrid connectivity, monitoring, and response. Enable centralized logging, CloudTrail, VPC flow logs, cloud audit logs. Use SIEM tools or security hubs for real-time threat detection. Establish incident response runbooks and conduct regular tabletop exercises. Operational hygiene. Patch and update OS/dependencies regularly. Scan container images and IIC templates for vulnerabilities in CI/CD. Rotate secrets and credentials automatically. Secrets Manager Vault.